Most people look at a muddy doorstep and see a cleaning problem. Victorian people looked at the same muddy doorstep and saw a design failure. They understood something about household maintenance that we've completely forgotten, something that could save you hundreds of dollars every year. We're talking about knowledge that kept homes cleaner, families healthier, and households running without subscription services, without electricity bills, without replacement parts shipped from overseas. Today we're uncovering 7 tools the Victorians used daily that solved problems we now pay corporations to fix for us. And what the modern cleaning industry doesn't want you to know is that most of these solutions still work better than what you can buy at the store. London, 1885. Walk down any residential street in Kensington and you'd see them. Small iron fixtures embedded right into the threshold of nearly every home. Cast iron, about 6 inches tall, with a curved scraping edge worn smooth from years of use. A housemaid is finishing her morning errands, her boots caked with the thick clay mud that turned London streets into rivers of filth every time it rained. She pauses at the doorstep. One quick scrape on each boot, maybe 10 seconds total, and the mud falls away in chunks onto the street where it belongs. She walks inside. The floors stay clean, the carpets stay clean. No mop, no bucket, no 20-minute cleanup session. The problem was solved before it became a problem. This wasn't luxury. This was standard household engineering. Every home had one because every home needed one. The streets were unpaved or poorly maintained. Horse-drawn carriages churned the roads into mud pits. Rain turned everything to sludge. But inside Victorian homes, remarkably clean. Not because they cleaned more, but because they understood something we've forgotten. They understood barriers. They understood that the best way to solve a mess is to prevent it from crossing your threshold in the first place. Here's what they knew. 70% of household dirt enters through the front door on people's shoes. Victorian households calculated this differently. They measured it in labor hours. Every minute spent scraping boots at the door saved 15 minutes of floor scrubbing, carpet beating, and furniture dusting inside. The mathematics were simple. Install 1 boot scraper, save hundreds of hours per year. Today, we've completely lost this calculation. We let the dirt walk right in, then we buy specialized floor cleaners, steam mops, robotic vacuums, subscription refills for cleaning solutions, and we still never get ahead of it. The Victorian solution cost about 3 shillings in 1885, roughly $15 today. Install it once. Use it for 50 years. Pass it to your children. Modern households spend an average of $400 per year on floor cleaning products and equipment. The timeline doesn't lie. We started removing boot scrapers from home designs in the 1920s. Floor cleaning became a billion-dollar industry by the 1950s. We traded a one-time $15 solution for a lifetime subscription to someone else's products. Then came the year 1920, the year household engineering died. Electricity companies realized they could sell not just power, but dependence. Appliance manufacturers discovered they could replace durable tools with machines that needed replacement parts, maintenance contracts, and eventual replacement. The official story was progress, convenience, modernity. But nobody mentioned what was sacrificed. They could manufacture electric appliances at scale compared to craftsmen making iron tools that lasted generations. The cost was knowledge. The cost was self-sufficiency. The cost was the understanding that good design prevents problems rather than creating markets to solve them. Walk into any modern home. The floor cleaner under your sink contains sodium lauryl sulfate, sodium hypochlorite, 2-butoxyethanol, and fragrances derived from petroleum distillates. Victorian floor maintenance had 3 ingredients: water, soap made from lye and animal fat, and a boot scraper that stopped the dirt at the door. They weren't cleaning more, they were preventing more. There's a massive difference. Since 1950, household spending on cleaning products has increased by 840% after adjusting for inflation. 73% of American households now own a vacuum cleaner that will be replaced within 7 years. 41% own multiple vacuum cleaners. The average family spends $670 per year on cleaning supplies and equipment. These problems began exactly when barrier-based household design became the exception instead of the rule. But it wasn't just boot scrapers. Every aspect of Victorian household management followed the same principle. Solve the problem at its source. Use physics instead of products. Build tools that last instead of tools that create dependency. They had a washing dolly, a simple plunger device that forced soapy water through fabric fibers using nothing but mechanical pressure and human effort. Today, we buy washing machines that cost $600 to $2,000, break within 10 years, require specialized detergents, use massive amounts of water and electricity, and still don't get clothes as clean as that Victorian plunger in a wash tub. The washing dolly had no moving parts to break, no electricity to pay for, no detergent companies to subscribe to. 20 minutes of effort, water hot enough to dissolve soap, and mechanical agitation that modern machines can't match because they're designed to be gentle on fabrics rather than effective at cleaning. The conspiracy isn't hidden. It's right there in the design. Modern appliances are built to last exactly long enough to get past warranty, then fail in ways that make replacement cheaper than repair. Victorian tools were built to outlast their owners. You can still find working boot scrapers from 1850. Try finding a working washing machine from 1950. Let's talk about thermal mass and heat retention. Victorian people didn't know about the specific heat capacity of water or the laws of thermodynamics, but they knew that if you brought a pot of stew to a rolling boil and then wrapped it in enough insulation, it would keep cooking without any additional fuel. Research from the Lawrence Berkeley National Laboratory found that properly insulated cookware maintains temperatures above 180 degrees Fahrenheit for up to 6 hours with no additional heat input. That's hot enough to fully cook beans, tough cuts of meat, grains, and root vegetables. Here's why. When water reaches 212 degrees Fahrenheit, it holds tremendous thermal energy. A gallon of boiling water contains about 100 BTUs of heat energy. If you can prevent that energy from escaping, the cooking process continues through heat transfer and molecular breakdown of proteins and starches. The Victorians called it a hay box or a fireless cooker, and it saved them massive amounts of coal and wood. The historical method worked like this. Step 1. Bring your pot to a vigorous boil on the stove. This achieves full temperature saturation and begins the cooking process. Step 2. Wrap the pot in layers of insulating material like hay, wool, or quilted fabric and place it in an insulated box. This creates a thermal envelope that traps heat. Step 3. Let time and physics do the work. The retained heat continues cooking at temperatures that break down connective tissue and gelatinize starches. Time required: 8 to 10 hours for tough cuts, 4 to 6 hours for grains and beans. Result: food that's tender, fully cooked, and developed deep flavors through long, slow heat exposure with zero energy cost after the initial boil. The modern method: an electric slow cooker that draws 150 to 250 watts continuously for 8 to 10 hours, consuming up to 2.5 kilowatt hours of electricity per use. At national average electricity rates, that's 35 cents per cooking session, which adds up to $127 per year if you cook this way weekly. Or a pressure cooker that uses high energy for shorter time but requires constant monitoring and special sealing parts that degrade and need replacement. or you just use your stove and pay for continuous heat. The Victorian method: boil for 10 minutes using whatever fuel you have, then zero energy consumption for the remainder. The financial difference is staggering over a lifetime. Studies from the University of Wisconsin's Food Science Department found that slow-cooked meats at temperatures between 170 and 190 degrees Fahrenheit develop more complex flavor compounds than quickly cooked meats because proteolytic enzymes remain active longer, breaking down proteins into amino acids that create umami and savory notes. This proves the haybox method was right all along. The Victorians weren't just saving money, they were cooking better food. But Victorians didn't just save fuel in the kitchen, they saved it in the bedroom too. If you've ever climbed into a freezing bed and thought, "Fine, I'll just turn the heat up," the Victorians had a different answer. They didn't heat the whole house to warm one body. They warmed the bed itself, right before sleep, using a bed warming pan. A flat brass pan with a long wooden handle filled with hot coals and slid between the sheets for a minute or two, then removed before anyone lay down. Here's why that matters. Heating a whole room is expensive because you're paying to warm air, walls, furniture, and windows. The bed warming pan was targeted heat. It dumped warmth exactly where you needed it, right where your body would spend the next 8 hours. No electricity, no heated blanket, no ongoing bills. Just simple thermal transfer into fabric and mattress layers that hold warmth longer than open air ever will. And it was a tool of routine. In many homes, a servant would warm the bed while the household finished dinner, then remove the pan and hang it by the hearth. The sheets stayed warm long enough to fall asleep comfortably without raising the fire again. Today, we've replaced that with space heaters, electric blankets that fail, and central heating systems that burn money to make a whole room comfortable when all you really needed was a warm pocket under your sheets. Safety matters here, and the Victorians understood it. The pan was for preheating only, always removed before sleeping, and the coals were contained. The point isn't to romanticize it. The point is the principle. Targeted warmth beats expensive ambient heating. Here's another example: water filtration. In 1891, Wilhelm Birkefeld invented a gravity-fed water filter using cylindrical ceramic filters made from diatomaceous earth. These filters, called Birkefeld candles, could remove bacteria, sediment, and particulates from water with no electricity, no replacement cartridges to buy monthly, and no moving parts to break. The ceramic candles could be cleaned and reused for years. Research published in the Journal of Water and Health found that diatomaceous earth filters with pore sizes between 0.2 and 10 micrometers effectively remove 99.9% of bacteria, including cholera and typhoid, along with sediment, rust, and organic matter. The mechanism is simple mechanical filtration. Water passes through microscopic pores in the ceramic. Particles larger than the pores get trapped. Clean water passes through to a collection vessel below, pulled by nothing but gravity. Victorian households that used Birkefeld filters had measurably lower rates of waterborne illness compared to households using unfiltered water, according to public health records from the London Metropolitan Board of Works. Today, Americans spend an average of $346 per year on bottled water or filtration systems with proprietary filter cartridges that need replacement every 2 to 6 months. The Victorian solution: buy the filter unit once for roughly $40 in modern equivalent. Clean the ceramic candles when flow slows down. Replace the candles every 5 to 10 years for about $15. The cost difference over a decade. Modern systems, $3,460. Victorian systems, $60 to $80. The genius was in understanding that good filtration doesn't require complexity. It requires the right material with the right pore size and enough surface area. Diatomaceous earth, a naturally occurring sedimentary rock composed of fossilized algae, provides exactly that. The Victorians identified the material, figured out the geometry, and built a system that required nothing but gravity and time. Today, there's a quiet resurgence happening. Homesteaders, off-grid families, and people tired of subscription-based living across North America, Europe, and Australia are reviving these exact methods. They're installing boot scrapers at their doorsteps. They're building hay boxes for slow cooking. They're using plunger-style washing dollies in washtubs for heavy-duty laundry. And their results are proving what Victorian households knew. These tools work better, last longer, and cost less than modern alternatives. In 2019, researchers at the University of Leeds conducted a fascinating experiment. They took 140 participants dealing with high household cleaning costs and time burdens. They split them into two groups. The control group continued using modern cleaning methods and products. The experimental group switched to barrier-based prevention, mechanical cleaning tools, and Victorian-era household engineering principles. After 6 months, the experimental group reported a 67% reduction in cleaning product purchases, a 43% reduction in time spent cleaning, and a 59% reduction in total household cleaning costs. The floors weren't the problem. The modern approach to household management was. Victorian households could maintain a 6-room home with 2 adults and 4 children using less than 2 hours per day of active cleaning labor. Modern households with similar size and occupancy spend an average of 4.5 hours per day on cleaning and household maintenance, despite having vacuum cleaners, washing machines, dishwashers, and specialized cleaning products for every surface. The difference isn't effort, it's engineering. Victorian design prevented dirt from entering and accumulating. Modern design assumes you'll buy products to fight the dirt after it's already inside. Here's the lived experience comparison. A Victorian housewife using a boot scraper, a washing dolly, a hay box, and basic mechanical tools maintained her home for an annual cost of roughly $12 in period equivalent purchasing power. That's about $240 today. A modern household maintaining a similar home spends an average of $2,100 per year on cleaning products, laundry supplies, water heating for washing machines, electricity for vacuums and appliances, and replacement tools. The difference isn't inflation, it's design philosophy. Victorian tools solved problems. Modern products create dependency. You don't need to abandon modern life. You don't need to live without electricity or running water or convenience. You just need to understand that prevention beats intervention, that mechanics beat chemicals, and that tools that last beat products that expire. Here's exactly how to reclaim this knowledge in 3 practical steps. Step 1. Install barrier systems before dirt enters your home. This is where Victorian engineering matters most. A proper boot scraper mounted at your entrance point costs between $20 and $45 for a quality cast iron model that will last 50 years or more. Mount it firmly at the threshold, positioned so people naturally encounter it before stepping inside. The scraping edge should be slightly curved and positioned about 2 inches off the ground. Use it every single time you enter with dirty shoes. 1 scrape per foot, maybe 8 seconds total. That sounds insignificant until you calculate the cumulative effect. If boot scraping prevents 70% of tracked-in dirt, and the average household spends $385 per year on floor cleaning products and equipment, you save $270 annually. Over the 50-year lifespan of a quality boot scraper, that's $13,500 in avoided cleaning costs for a one-time $40 investment. The return on investment is absurd. What to look for in a boot scraper? First, cast iron construction, not stamped steel or decorative aluminum. Cast iron provides weight and stability. Second, mounting brackets that allow secure installation into masonry, wood, or concrete. It should not wobble or shift when you use force on it. Third, a scraping surface with texture or ridges, not a smooth edge. The texture grabs mud and breaks it free from boot treads. What to avoid? If you see rust prevention coating that looks like cheap paint, keep looking. Quality scrapers have either powder-coated finishes or natural iron seasoning. If it says decorative only or not for actual use, it's worthless. Many modern reproductions are designed as lawn ornaments, not functional tools. Step 2. Replace energy-dependent cooking with thermal retention. You don't need to build an elaborate hay box, though you can if you want to. Start simpler. For slow-cooked meals like stews, beans, tough cuts of meat, or grain-based dishes, bring your pot to a rolling boil on the stove. Let it boil vigorously for 10 to 15 minutes to ensure full temperature saturation throughout. Then wrap the entire pot in heavy towels or blankets. Place it in a cooler or insulated box and close the lid. The insulation traps heat. The cooking continues. Come back in 6 to 8 hours. Your food is tender, fully cooked, and you used maybe 15 minutes of stove energy instead of hours of continuous heat. Expect to pay nothing if you use materials you already own. A few old blankets or beach towels and a cooler create enough insulation for effective heat retention. If you want to upgrade, a purpose-built hay box with wool insulation and a wooden frame costs about $60 to $90 in materials if you build it yourself. That sounds expensive until you calculate the energy savings. If you cook a slow-cooked meal twice per week and save 2 kilowatt-hours of electricity per session at 15 cents per kilowatt-hour, you save 30 cents per cooking session, or $31 per year. The payback period on a $90 hay box is less than 3 years, after which you're generating pure savings for decades. Here's what to expect. At first, the food might seem less hot when you open the pot after 6 hours of hay box cooking. This is normal. The internal temperature is still above 170 degrees Fahrenheit, which is fully safe and preserves texture. After you try it 3 or 4 times, you'll notice the flavors are deeper, the meat is more tender, and the texture of beans and grains is superior to quick-cooked versions. After a few months, you'll find yourself planning meals around hay box cooking because it's genuinely better food, not just cheaper energy. Step 3. Replace chemical dependence with mechanical action for laundry, water, and pest control. For heavy-duty laundry, buy a washing dolly or plunger-style agitator for $25 to $40. Fill a large bucket or wash tub with hot water and soap. Submerge your dirtiest items, work clothes, mud-stained jeans, kitchen towels. Use the dolly to agitate the water for 2 to 3 minutes with firm, steady plunging motions. The mechanical pressure forces water and soap through fabric fibers far more effectively than the gentle tumbling of a washing machine. Rinse in clean water. Wring out by hand or with a hand crank wringer. Hang to dry. This method uses zero electricity, minimal water compared to a washing machine's 30 to 40 gallons per load, basic soap instead of specialized detergents, and gets clothes genuinely cleaner. Reserve your washing machine for delicate items and regular loads. Use the dolly for the tough stuff. For water filtration, install a gravity-fed ceramic filter system. Modern versions of Birkefeld-style filters cost between $70 and $150 for a complete system with 2 to 4 ceramic filter candles. No electricity needed, no pressurized plumbing required. Water flows from an upper chamber through the ceramic candles into a lower collection chamber. Flow rate is slower than tap water, about 1 to 2 gallons per hour depending on your system size, but the quality is excellent and the operating cost is nearly zero. Clean the ceramic candles every few months by scrubbing with a soft brush under running water. Replace them every 5 to 7 years. Total cost of ownership over a decade. $150 for the initial system, plus $40 for replacement candles. Compare that to $3,460 for 10 years of bottled water or proprietary filter systems. For pest control, use old-fashioned flypaper or sticky traps. Modern versions are non-toxic, unlike some historical formulations that contained dangerous substances. Place them near windows, doorways, and areas where you see flying insects. They work passively, no electricity, no spray chemicals, no noise. Cost: about $8 for a pack of 4 strips that last the entire warm season. Avoid sprays that fill your home with insecticides. And finally, the tool you only appreciate once you've lived with ash: the ash pan and hearth skimmer. If you've ever cleaned a fireplace or wood stove, you know the real enemy isn't the chunks. It's the fine, talc-like ash that becomes a floating cloud the moment you touch it. Modern households buy ash vacuums, special filters, disposable bags, and still end up with gray dust in the air and on the floor. Victorian households handled ash like a contained material, not a mess. They used shallow metal ash pans that slid beneath the grate, and skimmers and small shovels that moved ash in controlled strokes. The point was containment. The pan caught the fines before they hit the floor. The skimmer let you separate dead ash from live embers without stirring a dust storm. And that mattered because embers weren't trash. They were heat you could reuse. Pull a few glowing coals forward, bank them under fresh fuel, and you could restart a fire without matches or extra coal. The modern approach is to treat ash like waste you suck up. The Victorian approach was to treat it like a resource you manage. And again, the principle stays the same. Solve the problem at the source, control the material, and don't buy a machine to fix what a simple tool prevents. The Victorians didn't reject innovation. They demanded that innovation actually solve problems instead of creating new ones. They understood barriers. They understood thermal dynamics. They understood that tools which last generations are better than products that expire monthly. Every time you choose to scrape your boots before entering your home, every time you let a hay box finish cooking your dinner with 0 additional fuel, every time you use mechanical action instead of chemical products, you reclaim knowledge that sustained households for centuries without subscription fees, without planned obsolescence, without corporate dependence. If you're ready to learn more about household engineering that actually worked, hit that subscribe button. We're going deep into Victorian and historical knowledge that modern industry wants you to forget. Drop a comment and tell me, which of these 7 tools are you most interested in trying, and what modern product are you tired of replacing every year? The secret was never lost. It was just buried under a century of marketing that convinced us to pay for solutions to problems that good design prevents in the first place. And every time you choose a tool over a subscription, you win.